Well, welcome everybody. This is going to be a very quick help video for standardizing data and comparing scores. So the math that they're asking us to do is they give us a formula for a z-score. A z-score is how many standard deviations away from the mean the raw score is. You need the mean, mu, and the sigma or standard deviation. So then that formula is x is the raw score minus the mean mu all over sigma, the standard deviation. When you plug that in, you'll get 26 minus 16 divided by 4. You can plug that into a calculator, your phone, an app. 26 minus 16 is 10. 10 fourths is 2.5. And that's what our z-score is. That's the formula we use for normalizing data or standardizing data, to use the standard normal curve. For more information of what that is and why we use it, reach out to me, work through your lessons, take a look at the class recordings. But right now, this is just the calculation portion of the quiz and what they're asking you to do. So that's a formula you're given, how to standardize data. You get a z-score. Yes, I'm still here. So for question 1, when they ask you how many standard deviations away from the mean, well, that's what the z-score is. And that's what that z formula does, is it converts our non-standardized data to a standard normal curve with a mean of 0, a standard deviation of 1. Therefore, the z, the standard deviations, whatever number it is how far away from the mean, the middle, it is. So if that doesn't make any sense, just keep thinking about it, try different things. Okay, so the z-score again, we're going to go ahead and bust out the calculator that's here on screen. We're going to try to remember that formula. We're just going to plug it in. All right, so the test scores of a student are normally distributed, okay? 92 is the average, nice, with a standard deviation of 3. What is the z-score of a student who scored 86 on the test? So again, just very quickly, we are normalizing the data, meaning we're going to make our mean 0. We'd expect most of our test scores to be centered around the mean. In the raw data, it's 92. In the raw data, the standard deviation is 3, meaning a score of 3 points higher or 3 points lower is 1 standard deviation away from the mean, so a 95 or an 89. The z-score of an 86, well, if 92 is here, we'd expect 86 over here. But we want to know how many standard deviations away, how much lower than the average score is it. And when we calculate our z, that'll tell us it's about this many below the mean. It's a z-score of 86, lets us know that it is a lower score than expected by this many standard deviations. So there's a brief introduction of what's going on there. But the math, again, is a z equals x, so our raw data point, which is 86, minus the mean, which is 92, right? I guess I can zoom in. There's the mean 92, divided by the standard deviation 3. We click equals, -2, -2. So it's 2 standard deviations below the average score on that test. Okay, that's question 2. Question 3. Suppose the number of gallons per day used by a car is normally distributed with a mean of 2.2 gallons and a standard deviation of 1.2 gallons. What is the difference in gallons per day used by a car with a z-score of 3 and another car that has a z-score of 0? So here we're comparing data using z-scores, but instead of using this formula where they give us the raw data, the mean, and the standard deviation, we're going to rearrange. We're going to solve for x and find the raw score data, and we're going to find that that's going to be the mean plus the z-score, times sigma, the standard deviation. We're going to have to do that twice because they're having us compare. Okay, so here we go. That's the calculation that we're being asked to use the what and the how. Again, watch those recordings, work through class, ask those great questions, and send me an email. We can talk about it. So the math right now is we're just going to use this raw score and find the gallons per day with the z-score of 3 and a z-score of 0 using the mean of 2.2 and the standard deviation of 1.2. So for the car that has a a z-score of 0, we'll call it x sub 0, is going to be equal to the mean, which is 2.2, plus the z-score of 0, so 0 times the standard deviation of 1.2. Well, 0 times anything is itself, so that's just going to be 2.2, and that makes sense because, again, the z-score is how far away it is from the mean. If it's a 0, it's right there on the average. The mean and the average are synonyms. Mean and average are synonyms. So if you have a z-score of 0, it is the mean. It is the average, which is 2.2. Okay, what about the z-score of 3? So now it's 3 standard deviations above the average use of fuel. So then we're going to do 2.2 plus 3. That's the z-score times 1.2. In our calculator, we will get, that's 3, 6, 5.8. You can put it in your calculator. All right, but we're not done because the final question is asking us what is the difference in gallons used. So now we're going to subtract those, right? So you do 2.2, take that away from 5.8, 6, 3. So 3.6 gallons more per day for a car who has a z-score of 3. Boom, right? Now, 3.6 gallons more a day times approximately $4 a gallon is, okay, $14.40 a day, approximately, for fuel, right? But if you're driving, 5 days a week for 4 weeks a month, that's times 20 days. That's a difference of $288 more if you buy a car with a z-score of 3. So I don't know, a month times 12, whew, almost $3,500 a year extra for that car. Okay. All right. Anyway, it pays to do the math. Sometimes it really pays to do the math, to think about the numerical logic in whatever decisions you're making, okay? Boop. Okay, this bar graph shows the z-scores for 4 employees, 2 different work weeks. Which employee had the least earnings for week 1? Okay, so let's zoom in. This is how do we read z-scores. So now they're charting the z-score. Right here, the z-score of 0 is the average weekly earnings. So if they're right here on this line or close to this line, it's their average weekly earning, their expected value of salary. But sometimes employees have opportunity to make more money, like working overtime or special tasks. And other times they're going to take some time off or travel, or they don't have paid time off, so they're going to make less money. So the weekly earning z-scores, remember, a positive z-score is higher than the mean. It's that many standard deviations higher than the average. So all of these positive ones are working more and getting more money. All of these down here in the negative are either working less or something happened, and they're making less money. So let's see, week 1 and week 2 are color coordinated. The question's asking us which employee had the least earnings for week 1. Looks like week 1, the blue. So this is the lowest, Oberto. So he earned the least amount of money for week 1 based on the average weekly earnings for these employees. 2 different work weeks, average expected earnings. Oberto, for some reason in week 1, maybe took some extra time off, earns the least based on these z-scores. Right, negative scores, it's below the mean. Positive scores, it's above the mean or the average expected salary or earnings. Cool. Ooh, the last one. Let's see, which question do we want to do? Hey. All right, so we got some throat lozengers here. These throat lozengers, I would have liked this question better if they talked about production, not different companies. Because yes, you do have comparing companies out there comparing products, and we actually just kind of rely on reviews and maybe bloggers, video people, TikTok, whatever, to give us our information and kind of show you the product. What are they called? Influencers, right? To compare companies of different products. But within that company, they might have two different assembly lines producing the same product, and they need to make sure that they are producing the same product. So they would do this random test and take some samples and find this information. So I wish it was assembly line A and assembly line B for the same company of throat lozengers. They found this happening. They found that the mean lozengers in a package was 38.2 for A and 36.9 for assembly line B. But the standard deviation was 1.7 for assembly line A. That's good. It's closer together. A smaller standard deviation means it's closer to the mean. Most of the data is closer to the center, and we want that, especially in production. Versus 2.4, okay, so the spread of the different values, it's a little bit more spread out. So we can expect a bigger variance in number of lozengers in the package versus a more consistent number, closer to the mean number of lozengers in the packages for assembly line A. Does that kind of make sense? That's the what behind what we're doing, or the why behind we're learning this math, or why would anybody do this math? They do this math, okay? This is a valid and important probability and statistics math that we use quite often in the world around us. Okay, so selecting from the drop-down menus, we're going to need to calculate their z-scores, but they don't tell you that, right? They kind of like just select from the drop-down menus. So let's scroll down and just talk about test-taking strategies. So here is the question. Select from the drop-down menus to correctly complete the statement. When you have that type of question, it's best to read the entire statement and then try to decide what it is you need to find to fill in those blanks. Since the z-score from blank is closer to 0 than the z-score of blank, the company that produced a package with 43 lozengers in it is most likely blank. So then we know we need to calculate the z-scores. Then we'll be able to put which company goes where. Then we need to calculate the z-score with 43 as our raw score, right? They don't tell you up here what your raw score is because we have that formula. Z is equal to X minus mu divided by sigma. So we need all three pieces of information to find those z-scores. So let's do it. Okay. So we know, I don't know if you heard that or not. That's a new bird sound. Okay, so we have, hold on. I want to use parentheses. We have 43 minus 38.2 parentheses divided by 1.7. It equals 2.82. So we'll write that down. 2.82. That's for A. Right? I used the values from A. Okay, clear. So now we have parentheses 43 minus 36.9 close parentheses divided by, 2.4, and that is equal to 2.58. That's company B. Okay, cool. So now we can answer these first two questions. The z-score from company B is closer to 0 because it's 2.58, so it's closer to 0, than the z-score of company A because company A was 2.82, right? So one was 2.5, the other one was 2.8. That means 43 lozengers, it's most likely going to be company B. What? Why? Well, the hint for test-taking strategies is since that one's closer to 0 than that, it means that the company is most likely, boom, right? So that's just a test-taking strategy. Since company B is here in the logic of the statement, company B should also go there. But as to why when it comes to the math, well, that has to do with what it means to have the probabilities under the curve, right? So this is company B. It's closer to the mean. than company A, but why is that true? So we'll talk about that some more, but that's the math behind today's quiz. So good job. Send me any questions and keep thinking.